All right, come here, sit down. It's time for some real talk. First, I'm making this video available as both the paid part of the course and freely to anybody. And sometimes I do that as sort of a marketing thing so you can see, if you're not enrolled, you can see what the real course videos look like. But this time I'm just doing it in the nature of a public service. Because this is how this goes. For those of you who are members of the paid course, every explanation that you've ever seen me give, every point that your score has increased, every bit of joy that you've experienced by getting better at the LSAT all goes back directly to the third game of PrepTest 40. And that's not hyperbole, because that was a game that was present during my training when I was working for some other company and they were training me. And the instructor did this bizarre magic when she was doing games. And, you know, she called it deductions, but it always seemed like it was really just backward-looking ad hoc nonsense. Pseudo-magic. And I never understood it. And then we got to that game, the third game of PrepTest 40, and none of her pseudo magic worked on it, and she turned us loose on it, and I had no idea what to do. So what I did is I just plowed my way through it. I tried to follow the directions of the game, and I tried to get it on the page, and that formed the core of everything else that I've done since. First of all, it told me that the basic principle for success in games is not your ability to master the nebulous nature of the essence of a game. That's stupid. No, the core essential principle for success on the game section, and this extends to the rest of the test as well, is your ability to be organized, to be systematic, and to just be fucking fierce. And here's what I mean by that. With that game, since I didn't know how to do any of that stupid magic, I just dove in and started writing. And it worked. So when I talk about being organized, I mean visually organized. I want to have something that I can see and understand by seeing it. And then systematic, I just want to keep carrying through the same thing every time as much as possible. And fierce, that's when I'm working with my pencil. I just get in there, get to work on the page and make it happen. And I do that by following those rules in a systematic, orderly, organized, visual fashion. And that is what I'm going to do here. And I think it's maybe a coincidence, but if it is, it's a really interesting one, that this game actually in all of its details reminds me very strongly of that third game from PrepTest 40. These are 2 of 3 games since PrepTest 32. 3 games that have not been highly susceptible to one of my main 5 templates. So it's unusual, it's weird, but it reminds me very much of the game that we saw in PrepTest 40, and this is how I'm going to attack it, with my pencil, in an organized, systematic, and fierce fashion. I'll start with the rules. How do I do anything with those rules? It transmits from somebody to somebody. Well, the thing that made sense to me is to move from the left to the right. And I don't want to use arrows myself, and that's part of systemization because I reserve those for conditional relationships. But when I say in Rule 1 that no computer transmitted to more than 2, I could say that by saying that some computer transmitted to 2, and I put that in a box, and it's just a visual reminder that that's the most transmissions you can get. It's not an exactly perfect replica of the first rule, but it's a visual reminder. Nobody does more than 2 connections. S connects to exactly 1, and you see I'll put a box around S. To me, that says that's S's only connection. Something will connect to both R and S, and that will be that thing's only connection, because Rule 1, nobody connects to more than 2. And then, of course, S will afterwards transmit to something else. And I'll say transmit or connect kind of interchangeably. Either R or T is transmitting to Q, and either T or U is transmitting to P. And then I am not going to try to shoehorn this into any previously administered schema. I am just going to follow the rules in a visually organized and very systematic fashion. Go down the list of rules every time. And this is what this looks like. Question 18. One possible route of the virus all the way to Q would be. All right, well, let's take those rules one by one. First, I'll start with rule 4, because if you're going to end at Q, you have to have come from R or T. But in answer choice C, you came from U. U does not transmit to Q. Get rid of C. And then I'll just kind of go through them one at a time. This doesn't show, any of these answer choices don't show somebody connecting to more than one computer, so I can't assess rule 1. But rule 2, S has to go to exactly one and only one. But look at answer choice E. There's no S listed, right? And we started the first computer. So that means wherever you branch S off, she's still got nobody to connect to. We've shown every other connection. And that violates rule 2. Get rid of E. Rule 3, there is some computer that connects to both R and S. And in answer choice B, we started at T, and T connects S, and S connects R. That's a violation of rule 3. T should connect to both R and S. And finally, P has to come from either T or U. And in answer choice A, we come from R to P. That's a violation of rule 5, so get rid of that. And that leaves us with only answer choice D, which I'm going to go ahead and show, because then at least I've got something to look back at. And here's the way I'll show it. It might look like 18 says UPRQ. And we know that something that connects to R also connects to S. And we know that S connects to one other thing, and 1, 2, 3, 4, 5, the only other thing left is T. All right, so there's one way that these computers could transmit that virus. I will take a more directive question next, so I'll start with question 20. If T did not transmit to any other computer, what must be true? Look, here is a place where T does not connect to any other computer. So anything that must be true will be true here. Now, just because it's true here doesn't mean it always must be true. But if there is anything that must be true, it must be true in this instance as well as in any other instance where T didn't transmit. Yeah? This is how this works. What must be true? A, P transmitted to S. That is true here. Does that mean that it always must be true? No, but it is true here. Answer choice B, Q transmitted to R. That is not true in this instance. That means that that answer does not have to be true, so it's not our answer. Get rid of it. U to S. That did not happen here. You went to P. It doesn't have to always be true. It's not our answer. Get rid of it. P did not transmit to any other computer. That is not true in this instance. That answer choice does not have to be true. Get rid of it. Answer choice E, R did not transmit to any other. That is not true in this instance, so that means it doesn't have to be true, so you can get rid of it. Now, I haven't proved in the traditional sense that A must be true, but what I have done is shown that B, C, D, and E all do not have to be true, so none of them can be our answer, and A then, by process of elimination, just is. All right, I'll come back to 19, I'll come back to 21 and 22. Ugh. I'll do 23, gives me something to do. If P is the only one that transmits to 2 other computers, what must be true? P is the only one that transmits to 2 other computers. Well, something has to transmit to R and S. And if P is the only one that's doubling up, P is going to be that one. And now there's 2 ways we could get to P. We could start at T or we could start at U. So I'm going to show those 2 ways. If we start at T, we've got Q next. Q has to come from R or T, and it's not coming from T, so it's coming from R. S has to connect to something, and that'll be the only thing left, which is U. So there's one way that P could be the only one that transmits twice. All right, here's the other way. What if we start at U? Well, S has to connect to somebody. Q could come from R or could come from T. Q can't come from S, so this is not Q. So it's the only things left. If we take off R, S, P, and U, and Q, then T is the only thing left, so S must transmit to T, and then Q has to come from either R or else T. We were asked what must be true. S to T doesn't have to happen. It could, but it doesn't have to. T to P doesn't have to. I mean, it could, but it doesn't have to. Q did not transmit to anybody. That's true. That's true. That must always be true in every instance. These are the only two instances. All right, I'll pick up with 19 and then 20 and 21. Or I'm sorry, 21 and 22. 19, what could be the computer that's infected from outside? We really could have handled this earlier. Look at these rules. P was not infected from outside. It's infected from T or U. Q was not. It was from either R or T. S was not. It was from some other computer that also infected R. R was not. It was from some other computer that also infected S. And that leaves us with only answer choice E, T. T might be the one that started it all. And the other possible answer that didn't appear here was U. U might be the one that started it all. 21. Any of the following computers could have transmitted the virus to two other computers, except, so the ones that could have gone to two other computers. Well, we have seen that P could transmit to two other computers, but that's the only thing we've seen. So we know that, and again, be careful, except. Answer choice A is true, so it's not our answer. All right. Could Q have gone to two other computers? Let's see. Here's answer choice B. Let's just make those computers R and S. And Q had to come from R or T, so it's not R, it's coming from T. And S has to go to one other thing, and we could make that thing, in that thing we have left U and P. That thing can't be P, so it would have to be U, but then U can go to P. So yeah, this works. Q could. Check it off. It's true. It's not our answer. Answer choice C. What about R? R is two other things, and we know that R itself is part of a branch. We know that S has to connect with one other thing. All right. Now, what do we know? This first one cannot be Q. It cannot be P. It would have to be, as we discussed in question 19, either T or U, right? So let's make it either T or U. If you're already seeing the problems with this, that's wonderful. And if you're not, hold on, you'll see in a second. All right, so if it's T, then we've got left P and Q and U. P has to come from U. So it's not here or here or here. But those are the only three places it can go. So P has no place to go. Or, do it with Q. Q has to come from R or T. So Q has to come here. U, and we get back to P. U can come from either one, but where does P go? Put U someplace and P, and suddenly that breaks the rule. All the way of saying that you can't do that. All right, well, what if we start with U here? Again, Q has to come from R or T. We've got Q, T, and P left. Q can come from R, but where does P go? P can't come from R. P can't come from S. That just won't work. And so answer choice C is false and is therefore our answer. And that then, no, does not quite finish. We've still got question 22, right? The spread is completely determined if which of the following is true. Let's use our work to our advantage. Answer choice A, if R transmits to Q. Well, here's a place where R could transmit to Q and U could start the whole thing. Here's a place where R transmits to Q and T starts the whole thing. R to Q does not then determine who starts. It doesn't determine everything. What about T to Q? Here's a place where T goes to Q and U starts the whole thing. Here's a place where T goes to Q and T starts the whole thing. T is not determinate. Okay? What about answer choice C? T transmits to S. Here, let me give myself a little bit of room. If T transmits to S, he also transmits to R. S has to transmit to something else. Now, Q had to come from either R or T, so Q is going to have to come from R. S has to transmit to something. We've got U and P left. So S doesn't go to P, S will have to go to U, and U will go to P. So that is determined, and that's what it looks like. Now, we don't have to do anything else. We've shown that answer choice C is the right answer, but what would it look like if an answer weren't determinate, and it weren't addressed in your other work? Just for fun, let's try that out. Answer choice E we know can't possibly determine everything, because answer choice C did. Well, what does it look like when it doesn't determine? All right, answer choice E, U goes to R. Well, U goes to R, she also goes to S. S has to go to something. We've got T and Q and P left. And S goes to not Q and not P. S has to go to T. And now P has to come from either T or U. It's going to have to be from T. So, it's looking determinate. But here's the thing. We've still got Q left. And Q could come from R. But she could also come from T. And while that is close, it does not determine where every computer got the virus from, and that's what it looks like when an answer is bad. Well, that was fun. To wrap it up, I just want to say that you don't have to get the game in some kind of big picture, deep understanding sense in order to succeed. What you do have to do is be visually organized, work systematically through the rules every time, and stay fierce by attacking with your pencil. Do the work so that you can see the work and not have to think through it. That finishes this game, and that finishes this section.